Okay, so this is a little walk around video for what we're going to do for a linear actuator. And right here, this uses a Siemens PLC. We've got the Siemens control panel. Over here we have the linear actuator, which actually what we have is the linear actuator down here that has a little carriage. And then over here we have three, I guess, little tubes or that we can fill, and we can fill it to various amounts what we have. And then we have the PLC control, and we'll show the controller some more over here. Now, our screen over here has some buttons that we can press and do different functions, but this is not going to be the type of control that the actual project is. But these are the commands that are used, and if we watch it, if we take these manual inputs, one drives it just jogging. This is jogging, and this will be towards the rear end. So if we hit that one, it'll jog that way, and it stays on until we turn off. And then we can go forward again, and it moves back towards us, and we'll stop it. Now if we go into the home position, and we jog it manually backwards, it's going to go until we have a sensor over there, and then it's going to stop. So now we'll move it, and now we'll bring it back, and it'll stop at that sensor. And now that it's stopped at that sensor, what we can do is we have these things that are move relative. And these relative ones, it'll move a certain position and then stop. And right now what we have it set up is when we hit this move clockwise, it'll be moving back towards the stepper motor. So that's where hopefully it'll be right underneath this one feed. And let's take a look. So it goes and it stops right there. Now if we do it again, it's going to stop under the second feed. So we'll move it again. And it stops right there under the second feed. And so rather than, you'll start out using these commands, and we'll take a look at the actual code itself. But these are just function blocks that you use. The actual screen that we're going to use for this is it'll have, three buttons, and they'll kind of basically say that we want to fill up, and we'll have a cup or we'll have some type of container underneath. But the first button will say we want to go to the first position and fill it up a third. The second one might be, well, we'll fill that up, I don't know, 40%. And then the last button will say whatever's left, I guess that's about 26%. But it'll be some kind of setup with that, and it'll have start and stop buttons rather than these buttons that say home or jog left, jog right, or move relative. But those functions will be in the program that'll have to be used. Now this has to be a Siemens S7 because these stepper motors, they require a lot of pulses per revolution, and so we need a high-speed output, and we don't have that on the Allen Bradley. So if you want to do this program, you're going to have to get used to the Siemens. This would also be, we have the Siemens HMI here. This might be a good program to take a look at the Wonderware. But just in a second, and we do have reference material. This is the booklet on how to control servo controllers using the pulse interface. And we'll take a look at the actual structure that we have in the PLC in a second. Okay, so here's what the PLC code looks like, and right now each of these blocks, all of our buttons, so this is the home position. This is a functional block that you use in there, and so you give it a command that says I want to go home, and we're operating off this axis, but when it gets to home we say that that's position 00, that's our reference, and there's different modes you can put it in. And one of the things that we need to do is we just have a sensor that you saw for the home position, but we also need end limit, hardware limit switches put into this. So if it overshoots for any reason, it can still recover. But we have the home position, and then all these for the move relative. You program these to make that move so it goes a certain distance. Down here, we also have some, this is the halt. Here's a command table that does some pretty cool stuff that you need to play with it. But this is the command that makes it move. And one, this is our manual that jogs forward, and this is the button that makes it move backwards. Now, when you operate this, or when you write this program, and this is considered, you know, a medium-sized program. It's not the tough one. It's not, you know, a simple 2-class type deal. But, you know, this is, depending on how you want to do it, it's maybe 4 classes to 6 classes if you want to get fancy and you want to use the wonderware. Part of what you're going to do with this is, so anyway, with the stepper motor, there's a technology object, and this is what you need to learn to know. And there's this axis, and then you configure it. And with this configuration, you go in there and you give it all the parameters that it needs to operate. And if it wants to come up here, so you can go in there, you can tell it what drive, and we're using pulse train output. And you know, your unit of measure, they talk in millimeters, or you can do it in inches. But they have drive, you have enable signals and whether it's ready, but then you get into the mechanics. And here we're operating at 6,400 pulses per revolution, and every time it makes one revolution, it goes about 15 millimeters, which is about 3/5 of an inch. So when it's operating back and forth, it's sending out a lot of pulses, you know, on the order of 25,000 pulses per second. So there's no way strictly a relay output from a PLC could do that. So you program these things, and then you put in, you know, your maximum velocity, how hard you want to accelerate or decelerate, and these are all programmed. Now, once you get it, and you'll start the program, it's going to be not in a very programmed position. You know, you're going to have to do all the programmings. But one big thing that this has on here is it has this commissioning. And you can turn on the commissioning function, and when you do that, and when it gets ready and enabled, you can turn it on, and now you can use these to, you know, take a look at, if I want to jog it and I want to go velocity of 20 millimeters, you know, what does that look like? Is that too fast or too slow? So if I hit the forward on here, you know, you can see that when I hold it down, it's going a lot slower than it did before. So you can go in here and say, well, you know, 20 is not going to be good enough for what I want to do. So you can play with these parameters. You can take a look at the velocity. You can take a look at the acceleration. You know, if you want to do the different type of homing, you can put in a homing mode, and you can set the home position, and you can make sure that it locks onto that home position, which is where our sensor is. Now, what we were talking about before is we're going to have a limit sensor over here, so if it overshoots the home position, it won't run into the end stop. If it hits this sensor, it'll say, you went too far, start going backwards. And if you do this program, you'd want to incorporate that, so you're going to have to add sensors. You know, it's a moderate program to do. There's wiring, a lot of wires to hook up, but you know, it's a pretty good project. Should be a pretty fun project. And you'll learn about the servo and the stepper motor, which is something you probably haven't seen yet. So that's our little linear actuator program that you can try.